Okay, so we just continue from here. 1.3 area of sector of a circle. Okay, so first let's look at the formula. Okay, so you can see here in the diagram on the right, the angle of sector POQ. So you can see POQ, the angle is this, which is theta. So it's at the center O of the circle is theta. So if theta is in degree, then the area of sector POQ is A equal to theta over 360 times pi r square. Okay, so this formula is actually using ratio. So what I mean by ratio is, you see in a whole circle, let's say I have a whole circle, so we know that the area is pi r square. So that's the area of the whole circle. So if now you have a sector, so a sector is basically part of the circle. So let's say it is theta. So this is part of the circle. So you want to find the area of this sector. So make sure you know what is sector. So sector is this, and that, the area here. Okay, so to find the area, so we are using theta over 360 to get the fractions of the whole circle, then multiply with pi r square. So it's basically using ratio. Okay, using ratio. So this will be the fractions multiply with the area of the whole circle. So let's say, for example, if I have theta equal to 60 degree, and then basically to find the area, 60 is basically 1 over 6. As you can see, the fraction here is 60 over 360, right? So it's basically 1 over 6 of the whole circle, which is pi r square. Pi, let's say I set up the radius here, 5. So 5 square. And then by pressing calculator, so 60 over 360 times pi. So normally we press the pi as well, and we will put our answer in decimal. So final answer 13.1. Yeah, 13.1. So that is the area of sector. So we use this formula if they are given, if theta is given in degree. So if theta is in radians, then the area of sector POQ is this formula. So just for your information, this formula is more important compared to the first one, because this chapter they focus on theta in radian. So 1 over 2 r square theta is the formula, and of course r is the radius, theta is angle in radian. Okay, now you can rearrange this formula so that r become the subject, and then you can find out the radius by substituting accordingly, even if you don't rearrange it into this form, right? So you can just substitute area, you can substitute theta, then you find r. You just move around and find r at the end. So this is another arrangement where we make theta as the subject, then you can get theta by substituting area and radius. Okay, so let's see some formula here. Okay, so you see our first part, find the area of each of the following sectors. Use pi equal to 3.142. So you see the example here. We have theta equal to 1.9. We have radius equal to 7.2 cm. So the area, you see they are using this formula, half r square theta. So half r square, so which is the radius power 2 times theta 1.9, and then you multiply and you will get the area, of sector 49.25. So this is the second example where they give us angle in degree. So we have to use this formula. This is one option. So of course the first option, the working is written here as alternative way. So angle in degree divided by 360 times pi r square. And then you get the answer. So if you are not using this way, there is another way. This method is the method where we change the 205 degree to radians. So that's why they multiply with pi over 180 to change it to radian. So just a quick revision again. So if you have degree, you want to change it to radian, you multiply with pi over 180. So if you want to do it the other way around, then you just multiply with 180 over pi. So they are changing degree to radian. So that's why they multiply with pi over 180, as you can see here. Then you get the answer in radian. And after that, they use this formula, A equal to half r squared theta. So you can see here, half r squared theta. Just substitute everything accordingly. Then you multiply and you will get the same answer. So it seems like this one you have to do 2 steps, and this one only 1 step straight away. So you can just decide on that. So on which way you want to use. Okay, so far is that okay for the first part?
Yeah.
Okay, so if you're okay with this, now let's move on. Okay, now for part B, complete the table below by filling in the values of A, R, or theta. Okay, so let's write down the formula here first so that it is more convenient for us. A equal to half r square theta. So you can rearrange it where you make r as the subject. So r equal to 2a over theta square root. And you can rearrange it so that theta become the subject. So theta equal to 2a over r square. So altogether there are 3 forms. So they are using it here. So let's see the example. So the first example, they give us radius 4.8, theta 1.25. So we are using this formula, half r square theta. Substitute, then you get the area 14.4 cm square. Okay, so second example, you can see here, they are using this formula where area and theta are given. So you can see here, theta is 1.28, area 23.04. Then they are using this formula, which is this one. Substitute the area, the theta, then you calculate and get the radius 6 cm. Okay, so I write here first, this is known as theta. Some people are not very sure on this symbol. This is theta. Okay, so let's move on. We look at the next one, the next example, as you can see here. Okay, so what happened is we have to find angle theta. So the formula is 2a over r square, as you can see here. So area is given 16.337. So we substitute on top. 6.2 is given. We substitute at the bottom. And then you press calculator and you will get this. Okay, so these are the 3 formula and the examples. Okay, now we start going to applications very soon. So you can see here, this is some application already, some extended formula. So you can see now they are asking about the area of segments. So what is segments again? You can look at the diagram. So these O, A, B, C is a sector. OABC is a sector. Segment is where when you draw a chord, AC is the chord. So what is meant by a chord? A chord must be a straight line from this point of the circumference to another point of the circumference, and then they form a chord. So then once you draw the chord, then the segment is here, and you want to find this area, this segment, area of segment. Okay, so the concept, you have to use area of sector, which is OABC, where we use half r squared theta to find the area of sector, and minus with the area of triangle OAC. So you can see OAC is the area of triangle. We have to minus that from the area of sector. So basically is where you take the big one, the sector, minus the triangle, then what remain is the segment. Okay, now you can see the area of the triangle. Area of triangle, 1/2 r squared sine theta. So 1/2 r squared sine theta is the area of triangle. Okay, so maybe you are wondering where is this formula coming from. So actually we have this general situation. If you have a triangle A, B, C, and let's say this is angle A, okay, so you want to find the area of this triangle, so we can just do 1/2 AB times AC times sine angle A. So basically this is the formula to find the area of triangle ABC. By the way, do you know this formula? Have you seen before? No, huh? Okay, so this is actually a formula that you're going to learn soon. Okay, so it's a general formula for whatever triangle. You just need to take one side that you know, another side that you know, and then after that you have to take the angle in between the two sides that you know. So if you are taking this side and this side, then you have to put the angle in between into the formula. Okay, so of course there are other versions also. If you have, let's say if you have the question give you the side AB and the side BC, then in that situation you have to use angle B. Okay, so what happens is, if you are given with side AB and side BC, then you have to put the angle in between of the two sides, so which is angle B. Okay, so likewise it can be this form also. If the question gives us BC and AC, and then we can use sine angle C. Okay, so these are the general situation. When it applied it to our situation here, right, our triangle is R, and theta. That is what we know. Okay, so we know the two sides here, which is the radius. This is also a radius, and the angle must be the angle in between. And we know that, and because of that, we have this formula. 1/2 R times R is something like this. R times sine theta. The theta is the angle in between. So basically it is this idea. And again, there is a concern that we need to be clear. This theta must be radian only. But this theta, right, it depends on your calculator. Depends on your calculator. So if your calculator is in degree mode, then this is degree. This theta is degree, but this is still radian. That means if you are given with an angle in degree, Then this one you can put degree if your calculator is in degree mode, but this one you must change it to radian mode in order to use this formula. Okay? So this depends on your calculator. But if your questions give you angle in radian, so what you can do is you can change your calculator to radian mode, and then this one you can use radian, and this one you can use radian. So that will be easier at most of the time. So for example, you can see here the angle given is in radian, 2.6 rad. Then they're using this formula, which is this one. They factorize the half r square from here and here, so that the formula becomes this. So half r square theta minus sine theta. So they highlight here also, make sure the calculator is in radian mode in order to put radian here. So if your calculator is in degree mode, you have to put degree here. Then you press calculator straight away, then you will get this. Okay, so that is how we use the formula, and let's move on. Okay, let's see what we have over here. Okay, so let's see one problem solving then. Problem solving. Okay, so over here, let's look at this example straight away. Solve each of the following problems. The diagram shows a semicircle OACB. M is the midpoint of OC. Okay, so this is the midpoint of OC. This is, after all, this is the radius. Okay, now A, find angle OBD in radian. Angle OBD in radian. That means you have to find this angle. Okay, let me mark it down. So we need to find out this angle OBD. Okay, so what they show here is actually tangent. They are using tangent. So why they use tangent? Because there's a right angle triangle here. OBM is a right angle triangle, so that's why they are using tangent. So you know tangent equal to opposite over adjacent. So that's why tangent angle OBD is equal to opposite. This is the opposite, OM, yeah, over OB. Yeah, OB is the adjacent. Okay, so OM, they know is 4 because this is the midpoint, and the whole line is the radius 8 cm. Same with this one. This is also radius. So because this is midpoint, so it's the 8 cm just now, the radius which is 8 cm, is divided into 4 cm and 4 cm. So that's why this is 4. Okay, so here is 4. Here is also 4. They are same length. Okay, so that's why OM is 4 cm over 8. Over 8. So opposite over adjacent, then you get 1 over 2. And after that, you shift the tangent over, inverse tangent half, then you will get this. You will get this if your calculator is in radian mode. So if your calculator is in degree mode, you inverse tangent half, right? You will get answer in degree. Then you need to convert later by using formula. They want answer in radian. It's written here. Okay, so that is the first part. Now we look at B. In triangle OBD, we look at the question first. Calculate the area of the shaded segment BCDM. BCDM. Okay, this segment, the shaded regions, is known as the segment. Okay, so our problem is we need this angle. We need this angle so that we can use the formula, which is half r squared theta minus sine theta. Okay, so we need to find out the angle. The angle that we are looking for is this angle. Is this one. So we are looking for this angle. Okay, we need to know that angle before we can use the formula. Okay, now let's see the working here. Angle OBD equal to angle ODB. Okay, so let's see where OBD, which is this one, equal to ODB, okay, which is this one. This and this are same, basically because this is an isosceles triangle. Okay, isosceles triangle, imagine this is radius, this is also radius, same length. Okay, OB and OD are same length, so they are known as isosceles triangle. So isosceles triangle has the same base angle. These two are the base angle, they are same. So since you know this is 0.4636, which is here, then this will be 0.4636 as well. Okay, so they found it. And after that, angle BOD, which is this one, the one that I put with question marks, is equal to pi minus 2 of this. That means pi minus this one and that one, then you will get this. So what is meant by pi here? If you still remember, pi is in radian actually, is equal to 180 degree. So they use pi because a triangle has a total angle of pi, a total angle of 180 degree. In other words, that means this angle plus this angle plus this angle is equal to 180 degree or pi radian. So in order to find this, we use pi minus this and that. So that's why you see the working, pi minus 2 of that angle, then you get the angle 2.215. So once you get that, you get the angle here, and then you can use the formula. So where the formula is area equal to half r squared theta minus sine theta. So this is the formula to find the area of the segment. Okay, so now they put the angle inside. So as you can see, they put the angle 2.215, and then I put the radius 8 cm, and then I get the area of segment. Okay, so I will let you try questions. Let's see what else first. As what I said just now, we need to finish up the whole chapter. Okay, let's see. So we have application. Okay, that means we need to use everything that we learn to solve questions. Okay, so what we have learned in these chapters, let's take a quick look again. So we learn how to change degree to radian, where we have to times pi over 180. We learn how to change radian to degree, times 180 over pi. We also learn how to find the arc length, which is this one. This is theta, this is r. So S equal to r theta. Okay, so if theta is in radian, so if theta is in degree, then the way to find arc length is S equal to r times theta times pi over 180. Okay, so basically what happened is you just need to change the angle in degree to radian, which is based on this formula, theta times pi over 180 to change it to radian, and then you times r again. Okay, so this is theta in degree. Now the third one, this one, the chord length, 2r sine theta over 2. So this is another one that you need to know. This is the chord length. Then just now we learned area of sector. So A equal to half r squared theta, or A equal to theta over 360 times pi r squared. Okay, so this is in radian, this is in degree. Then we also learned the last one, the area of segment, half r squared theta minus sine theta. So it seems like we don't have much thing here. This chapter 5 formula, okay, so and we applied it in questions. So of course when we do question like this, sometimes we need to use critical thinking. Okay, let's see. The diagram shows the cross sections of a cylindrical water container with a radius of 30 cm. So as you can see, OA is the radius, 30 cm is the radius. The container is filled with water until the water surface AB is 20 cm above the center O. 20 cm. Okay. Find the percentage of the container that is filled with water. Percentage of the container. Okay, so we want to find the percentage of water. Okay, so to do that, let's see what they do here. You see, basically, right, you want to find percentage of the container that is filled with water, right? So you have to get some general knowledge first on how to make it happen. Okay, so then you have direction. You see, what we need to do is we need to find out the area of the shaded region, divide by the area of the whole circle, then you times 100%. So basically this is our general idea. Area of the shaded region divided by area of the whole circle times 100%, then you will get the percentage of container filled with water. So they are trying to work it out to find out the area of the shaded region. Okay, so what they do first, they are finding cos angle AON. So try to imagine AON is a right angle triangle, and you want to find this angle. Okay. So what to do is, in this right angle triangle, we know the adjacent, the hypotenuse, so they use cos. Cos is adjacent over hypotenuse. Then they shift the cos over, inverse cos, they get the angle in radian. And that is this angle. Now you see the times 2. The times 2 because they want to find the whole angle of this triangle. Okay, so that is the second step. The second step is they are trying to find this in blue color. Okay, so now to find the area of the shaded major sector, so they are doing 1 over 2 30 square, which is the radius, 30 square, 2 pi minus 1.6822. Okay, so if you're wondering what happened here, okay, so I just explain a bit. This is actually the formula that we learned just now, 1 over 2 r squared theta. They are using this formula. It's just that we have to know, I put it in two situations. So when you use half equal to, when you use a equal to half r squared theta, right? So there are actually two situations. If your theta is acute angle, then you will get the sector, which is called the minor sector. But in case if you want to find out the major sector, so what to do is you have to use the angle outside. Okay, make angle outside, which is this one. Okay, angle outside here to here. Okay, maybe I put an extra note here. So if you have a circle like this, this is theta. Here is 2 pi minus theta. So why 2 pi? Because 2 pi is 360 degree, and we have to know that in a circle that there is a total angle of 360 degree in the center. Okay, so 2 pi minus this one, and then you get the angle outside. And then based on this formula, right, if you do area equal to 1 over 2 r squared 2 pi minus theta, and then you will get the area of the major sector, which is here. Okay, so this is where this is the extended one. Okay, now let's see. Let's come back to this. Okay, so when they use this formula, 1 over 2 r squared 2 pi minus theta. Okay, so let's say I just follow what I wrote in the note just now. So if you are using that 2 pi minus theta, so you are finding the area of the major sector, which is here. Okay, you are finding that, the blue one, and because of that they have to add with the area of the triangle. So area of triangle is 1 over 2 r squared sine theta. This one we discussed just now. Okay, they are using that formula, 1 over 2 r squared sine theta, and they are finding this area of triangle. So as you can see here, radius 30 square, area of triangle sine 1.6822. So 1 over 2 r squared sine theta, where they get this green region. So the blue region add up with the green region, then you get the area of the shaded major sector. So which means the area of the shaded region. Okay, now yes, yeah.
The triangle, right, can just like times 20 then times 30 then divide by 2.
If you know in a triangle, right, you can do so when you know the base and the height. 1 over 2 times base times height. Okay. The problem here is the 20 is the height, but 30 is not the base. The base is this one. We don't know that. So that's why we cannot do 1 over 2 times 30 times 20. So because we don't know that. So that's why they use this. Okay. Yeah, then they get the area of the shaded region, then divide by the area of the whole circle. Pi 30 square is the area of the whole circle, times 100%, and then you will get the percentage. Okay, so let's see what else. I think this chapter is almost settled already. Okay, so they give us all kind of problem solving we need to go through after this, and then SPM practice again. Okay, so finish this chapter.